Okay, now the topic of discussion is free fall. Okay, whenever the object is released from certain height near the surface of the earth, say for example, if I release this duster without applying the force, okay, just you have to release it. This kind of phenomenon is called the free fall. So object is released near the surface of the earth will be accelerated. Now this motion is an accelerated motion because of the gravitational force of the earth. So velocity will continuously increase. Okay. So the force due to earth's gravity will produce the accelerated motion in the downward direction, and you know that magnitude of gravitational acceleration g is taken to be 9.8 meter per second square. Now see, here this vertical direction of motion is taken just now, or rather previous studies we have taken the direction of motion to be x-axis. Here you are taking the direction of motion as y-axis. Now see, when you are releasing this object from this particular point, then this point from where you are releasing is your initial position and you take it as origin, that is 0. So point of release is 0. So now you are moving in downward direction. Now downward direction y-axis, okay, from 0 in the downward direction, from 0 in the downward direction on y-axis, the values will be negative. So these values of displacement are taken negative. So minus 10, minus 20, minus 30, minus 40, that way in meter I have taken. This is the time. Okay. Now as velocity gradually increases, so unequal distances will be travelled in same time interval. So this is a case of non-uniform motion. Non-uniform motion but with uniform acceleration. Acceleration is same. What is the value? 9.8 meter per second square. So constant acceleration but uniform motion is not there. It is non-uniform motion. Unequal distances are travelled in same time interval. So curve graph you will have. Y is taken negative. Okay. So the value of y is minus 10, minus 20, that way it is taken. Okay, g is 9.8 meter per second square, but it is moving in downward direction, and that is why it is written as minus g. Now minus value means retarded motion, generally we have studied, but right now it is an accelerated motion, velocity continuously increases, but to show that acceleration is in negative y direction, it is taken to be minus. Okay, v0 initial velocity is 0. Now try to understand. We draw the graph of velocity versus time. Velocity gradually increases. So initially in 1 second, say it is minus 10 or say around about 9.8. Okay. So minus 10, 20, that way the value of velocity gradually increases. In first second it was 10, at 2 seconds it becomes around about 20, exactly 19.6. That way its value of velocity gradually increases. So it's a linear graph. Same increase in velocity in same time interval. Okay. So this is a linear graph of velocity versus time. And displacement versus time is a curve graph. So this is non-uniform motion but with constant acceleration. Now our equation is that v is equal to v0 plus at. Now v, that is final velocity, is equal to v0. V0 is 0 as we are releasing with 0 velocity, so 0 minus gt. Then displacement x is equal to v0 t plus half at square. Now v0 is 0, so y is equal to 0 minus 1 half gt square. Here a is replaced by minus g and v0 is replaced increased by 0. Similarly, b square minus c0 square is equal to 2ax. So here b square minus 0 is equal to minus 2gy. Okay, so these are the equations for the free falling body for simplicity. When the object is released, okay, when the object is released. In calculation, for simplicity, we take g as positive because we have this habit of positive value means increase in velocity, means it is accelerated motion, and when there is minus value we understand that it is an anti-acceleration or retardation. So for simplicity, for the calculation, we write this way for freely falling body. Then this v will not be minus, then velocity will be positive. So try to understand when the object is moving in downward direction, then its velocity will be negative. So this minus and minus, when you put this become plus. But for our simplicity of calculation, we will write positive g for the different equations. So the equations can be written as v is equal to 0 plus gt. You can write and calculate, but you have to understand that object is moving in downward direction. So it can be shown to be negative displacement, or displacement can be shown in negative value. But for calculation and for simplicity, you can write v is equal to 0 plus gt, y is equal to 0 plus 1 half gt square, and v square is equal to positive g. Positive 2 into gy. This can be done. This can be used for calculation. Now there is a topic of stopping distance. Now whenever brakes are applied, now see, brakes are applied, then the acceleration produced is negative, or we can say it is anti-acceleration or retardation. The value of velocity gradually decreases. So distance traveled before stopping, when the brakes are applied, is called the stopping distance. You do not stop immediately. When you apply the brake, you travel certain distance. So that distance traveled is known as the stopping distance before the object stops. And brakes are applied. So stopping distance you want to find, use this equation v square minus v0 square is equal to 2ax. Now acceleration is negative, so a is taken to be minus a. Retardation. Now don't confuse in this. Okay, retardation means you have to take minus a. You take the freely falling, for freely falling body, you take g as positive for calculation. And when the object is thrown in upward direction like this, then velocity gradually reduces, finally it becomes 0. Okay, so in that case, when the object is thrown in upward direction, you take g as minus. Okay, so the calculation part becomes easy. And that is our conventional understanding also. So a is taken to be minus a because brakes are applied. So minus v0 square is equal to minus 2ax. Now x can be taken as subject of formula, it becomes v0 square upon 2a, and this becomes the stopping distance. Okay. Now we move further for the relative velocity. Now relative velocity is the velocity of object with respect to the other one. Now this you try to understand, the two objects are beginning their motion from the same position, say 0, 0. Both are together. Okay. Now one is moving faster, the other one is moving slower. If both are moving together with same, then there will be no relative change in their position. Try to understand. Both are moving together with same velocity in same direction, then there will not be any relative change in their position. But one is moving faster, the other one is moving slower. Say for example A and B are two objects, both are in same position initially. So A is having, say, velocity, it is moving with constant velocity VA and V is moving with constant velocity VB. Okay. Now, distance traveled by both in same time interval of t will be from here they are beginning. So initial position is for A is x0a and distance traveled is velocity multiplied by time. So VA into time interval. So VA into V will be added. So its position, rather XA will give you the position of A at time t. Position of A at time t can be XA is equal to initial position plus whatever he has covered, that is VA into t. Similarly, XB can be initial position plus the distance covered by him, that is VB into t. Now, sir, if I take one example, then you can understand it very easy. See, A is moving with 40 km per hour. I write 40 km per hour. And B is moving with 60 km per hour. Now, both are at velocity. Both are at same position and they are moving in same direction. One is at 40, the other one is at 60 km per hour, constant velocity. Then after 1 hour, A will be having its position at say 40 km and B will be having its position at 60 km. Now, what is the relative position of B with respect to A? So we can say he is 20 km ahead of A or 20 km ahead or in positive direction of A, ahead by 20 km from A in positive direction. So position of B minus position of A at time t. At time t means at 1 hour. So at 1 hour he is at 60 km, he is at 40 km. So position of B with respect to A is xb minus xa. So same thing has done here, xb minus xa. So subtraction of these two equations, this minus this. So it is written here. Now both are at same position. So this xb0 and xa0 are same. So they will be cancelled out. So now you will have vbt minus vat. T can be taken as common, so it becomes VB minus VA. Now, XB minus XA upon T if you take, then it will be VB minus VA and XB minus XA upon T is nothing but velocity of B with respect to A, that is VB minus VA. This example clearly shows that velocity of B with respect to A, after 1 hour we can say the distance between them is 20 km. So after 1 hour there will be, or we can say velocity of B with respect to A is 20 km positive, that is more than A, 20 km per hour more than A. Or we can say VBA is equal to simply VB minus VA. And if you want to write VA minus VB, then 20 km behind. So VA minus VB if you write, then this becomes VA minus VB, and this becomes VA is 40 minus 60. So 40 minus 60 you will get minus 20 km per hour. It means he is behind. That is in negative direction from B, or A is behind B by 20 km, we can say. So VA minus VB and VB minus V. VA minus VB will give you relative velocity of A with respect to B, while VB minus VA will give you velocity of B with respect to A. Okay. Now, if both the objects, one is here, the other one is ahead of me. So I want 10 kilometer mark or 10 meter mark, and my friend is on 20 meter mark, and both are moving with constant velocity in one direction. What is the distance between us? Relative distance. I am on 10, my friend is on 20, so relative distance is 10. Both are moving with same speed, same velocity. Okay, same velocity. Magnitude of speed is same, direction is same. Now both are moving with same, then the distance between them will be maintained that of 10 kilometers. So if they are moving with same speed, keeping some distance between them initially, then they will never meet, or their x versus t graph will be parallel to each other. So x versus t for A and x versus t for B will be parallel. Now, keep some distance here. Another example, that I am here, my friend is ahead. Okay. Now, say A is me, A is behind, B is in front. Okay. My velocity, value of velocity is more than the other person. Then what will happen? Then I will overtake the B after some time. So if I am here at 10 and my friend is at 40, or A is at 10 and he is at 40, okay, but my value of velocity, both are moving in same direction. My value of velocity is more than that of the other person who was in front, or he was, say, ahead of me. Okay. Then also after some time I will overtake. So wherever these two are intersecting, there the graphs of x versus t of both the objects, wherever they are intersecting, will give you the position and time at which one overtakes the B. Okay. So this are the concept of relative velocity. Try to read 2-3 times, understand it. Okay. Thank you very much.